Lesson 3, Interpreting and Computing Division of a Fraction by a Fraction. More models. Our goal: use visual models such as fraction bars and area models to show the division of fractions by fractions with common denominators. Divide fractions by fractions with common denominators by using models. Our first classwork says, draw a model to represent 12 divided by 3. Or we can write this as 12 as a numerator and 3 as a denominator. That's still 12 divided by 3. Or it could look like this with the division box, 12 being the dividend, 3 being the divisor, and we're looking for the quotient, the answer to that. So what we can do, if we want 12 and we want to divide that by 3, well, this whole thing here could be the 12, the whole. If we want to divide it by 3, there are 3 separate boxes already set up for that. So how much would go in each of these boxes if I were to split the 12 wholes into 3 groups? Well, it would be 4. And that would be a model to show 12 divided by 3 equaling 4. Example 1, draw a model to show the division problem. 8/9 divided by 2/9. This visual that I have here, and there's 1, 2, 3, 4, 5, 6, 7, 8 out of the 9 that are shaded. You can think about this as how many groups of 2/9 are there in 8/9. So because they have the same denominator, it makes it really easy. What I can do is circle 2 out of the 9, another 2/9, a third set of 2/9, and one last set of 2/9. So you can easily see how many groups of 2/9 are there in 8/9. There are 1, 2, 3, 4 groups. And if you look at our problem, it's easy to see that 8 divided by 2 is 4. Because these have the same denominators, 9 divided by 9 would be 1, and 4 over 1 is the same as 4. Example 2, draw a model to show the division problem. 9/12 divided by 3/12. Again, we can think of this as how many 3/12, how many groups of 3/12 are there in 9/12? And again, they have the same denominator, so it can make it really easy for us by circling groups of 3, which represent 3/12. One group of 3/12, another group of 3/12, and one more group of 3/12. So how many groups are there of 3/12 and 9/12? You should say 3. If, again, you look at the numerators here, 9 divided by 3 is 3, 12 divided by 12 is 1, 3 over 1 is the same as 3. Example 3, draw a model to show the division problem. 7/9 divided by 3/9. Again, we are asking how many groups of 3/9 are there in 7/9. So here's my model. I'm going to circle groups of 3. Here's 3 out of the 9. Here's another group of 3 out of the 9. And even though there's only one more shaded, I'm still going to circle a group of 3. Because again, these are groups of 3/9. But my answer will not be 3 wholes. How many wholes are there? Well, there are 2 groups that are fully shaded. And here we have a partial group. How many out of that group is shaded? There's 1 shaded out of 3. So that's how I could represent this answer. There are 2 full groups, and there's part of a group, 1 out of the 3 are shaded. So if I were to divide 7 by 3, I would get 2, because 2 times 3 is 6. There'd be 1 left over out of the 3. So again, that answer is 2 1/3. I have 2 more examples here. Draw a model to show the division problem for 11/4 divided by 3/4. So this is a little bit different because this is improper. The numerator is larger than the denominator. So the way that we do this is we show 4/4 here, another 4/4, which would make 8/4, and then another, and there's only 3 out of the 4 shaded, because if we have 8, we need 9, 10, 11, so this shows 3/4. But but you can see how it's groups of fourths, 4 fourths, then 8 fourths, 9, 10, 11 fourths. So if we want to separate them in groups of 3 fourths, I would circle groups of 3. One group of 3, another group of 3, a group of 3 here, and then I just have enough for a group of 3, although there's only partial shaded. So just like the previous example, I want to take the holes for the ones that are all the way shaded. There are 1, 2, 3 groups that have everything shaded, so that would make 3 holes. And I have some that are partially shaded here. So it would be 2 out of the 3. And again, if you were to divide 11 by 3, because the denominators are the same, you would get 3 2/3. So again, because it's improper, I kind of stack the rows, show 4 fourths, another 4 fourths, and then this will represent 3 fourths to make a total of 4, 8, 11 fourths for the visual. For the last one, 13 tenths divided by 2 tenths. Again, here I have 10 tenths, and because I have improper, I'm adding another row underneath, so I have another 3 tenths shaded. And if I need to circle it in groups of 2, I can do it like this, group of 2 tenths, 2 tenths, 2 tenths, 2 tenths, 2 tenths, and then I only have 1 out of the 2, but I still circled 2, and I count how many groups, solid groups I have. 1, 2, 3, 4, 5, 6 are completely filled in, and then this last one, there are 1 shaded out of the 2, so it would be 1/2. Again, if you were to divide 13 by 2, you'll get 6 with 1 left over, so it would be 1/2. 6 1/2. Please make sure that you do your reflection. In your composition, you should be writing a question or a comment, and then also rate yourself if you are green, yellow, or red based on this lesson, how you feel. If you're able to, please provide your own example with a model representing your answer.